Right now, above your head, on the other side of a stretch of space so vast it breaks the human brain to actually picture it, there is a place, a real place. Not a theory, not a simulation, not a mathematical abstraction scribbled on a whiteboard somewhere. An actual location in the universe, currently existing, right this second, roughly 34 billion light years away from the chair you're sitting in. And here's the part that should genuinely unsettle you. The light we're using to study that place left it before the Earth even had a moon-sized companion locked into a stable orbit, before our solar system existed in any recognizable form, before almost every atom in your body had even been forged inside a star. That light has been traveling uninterrupted for over 13.5 billion years, just to finally land on a mirror the size of a tennis court, floating 1 million miles from where you're standing. And when it finally arrived, it told us something almost impossible to accept. We are looking at the single most distant known place in the entire universe, and everything we thought we understood about how quickly the universe should have organized itself into something like that may be wrong. Let's be precise about what we're actually talking about, because precision is the only thing that separates a real scientific discovery from an exaggerated headline. In January 2026, astronomers using NASA's James Webb Space Telescope confirmed the existence of a galaxy called MOEM-Z14, and declared it, officially on the record, the most distant object ever measured by humanity. Not the most distant guess, not the most distant candidate, the most distant confirmed object, verified through direct spectroscopic measurement, the gold standard of astronomical distance checking. The team was led by Rohan Naidu, an astronomer at MIT's Kavli Institute for Astrophysics and Space Research, and their findings were published in the peer-reviewed Open Journal of Astrophysics. What they found was a galaxy sitting at a redshift of 14.44, existing as it appeared just 280 million years after the Big Bang. To put that in perspective, if the entire 13.8 billion year history of the universe were compressed into a single calendar year, MOEM-Z14 would represent a moment occurring within the first 7 hours of January 1st. Now here's where this gets genuinely strange, in a way that most explanations of distant galaxies gloss right over. When we say MOEM-Z14 is 33.8 billion light years away, we're not talking about how far the light traveled to reach us. The light itself only traveled 13.53 billion years, which sounds like it should mean the galaxy is 13.53 billion light years away. But the universe has been expanding this entire time, stretching the space between us and that galaxy like a rubber sheet being pulled apart in every direction at once. By the time that ancient light finally reached Webb's mirror, the galaxy that emitted it had already drifted much, much farther away, carried outward by the relentless expansion of space itself. Astronomers call this the difference between light travel distance and proper distance. And it's the reason MOEM-Z14's current position, right now, in this moment, sits at roughly 33.8 billion light years from Earth. Even though its light is only 13.53 billion years old, the place we're looking at technically doesn't even look like what we're seeing anymore. It has kept existing, kept aging, kept evolving for over 13 billion years since that light left it. We're looking at a ghost of a place, and the place itself has almost certainly transformed into something completely different by now. Here's what makes MOEM-Z14 more than just a new number on a leaderboard. This isn't a small, faint, barely detectable smudge of light hovering at the theoretical edge of what our instruments can pick up. According to the research team, MOEM-Z14 is remarkably luminous and compact, with an effective radius of only about 241 light years, making it roughly 1% the size of the Milky Way. And yet it's bright, genuinely, surprisingly bright, for something that formed so unbelievably early in cosmic history. Before Webb ever launched, cosmological models predicted there would only be a small handful of developed galaxies this soon after the Big Bang. Tiny, disorganized, barely formed clusters of the earliest stars. Instead, initial imagery from Webb's deep field surveys revealed roughly 100 times more of these bright, structured objects than anyone expected. And MOEM-Z14 sits right at the extreme edge of that unexpected population. Naidu put it plainly in NASA's own statement. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted, which is both challenging and exciting. It gets even stranger under the surface. The stars inside MOEM-Z14 appear to contain more nitrogen than astronomers expected to find in a galaxy this young, a subtle but important chemical clue suggesting that whatever process built these stars, it moved faster or worked differently than the models currently account for. Jacob Shen, a postdoctoral researcher at MIT and a member of the Discovery team, described the situation in stark terms. There is a growing chasm between theory and observation related to the early universe, one that presents compelling questions still waiting to be explored. When a scientist uses the word chasm to describe the gap between prediction and reality, that's not casual language. That's an acknowledgement that something in the foundational understanding of how galaxies form needs serious re-examination. It's worth pausing to understand exactly how astronomers can be so confident about a claim this extraordinary, because confirming a place is the most distant known location in the universe isn't as simple as pointing a telescope and eyeballing a faint smudge of light. The method relies on something called redshift, and it works because of a very specific and very reliable property of physics. As the universe expands, it stretches the wavelength of light traveling through it, shifting that light toward the red end of the spectrum, the same way the pitch of an ambulance siren drops as it speeds away from you. The farther away an object is, and the longer its light has been traveling through an expanding universe, the more dramatically that light gets stretched and the higher its measured redshift becomes. For MOMZ-14, astronomers used Webb's near-infrared spectrograph, an instrument sensitive enough to break the galaxy's faint light apart into its individual wavelength. Components searching for a very specific, well-understood signature called the Lyman break, a feature caused by a neutral hydrogen gas absorbing certain wavelengths of light in a predictable pattern. When that signature showed up exactly where the math predicted it should for a redshift of 14.44, the measurement stopped being an estimate and became a spectroscopically confirmed fact, the gold standard that separates a verified discovery from a hopeful guess. This is precisely why astronomers were so careful to point out that MOMZ-14's distance wasn't merely inferred from its color or brightness in a single image, the way many early candidate galaxies are first flagged. It was confirmed through direct spectroscopy, the same rigorous process used to verify every previous record holder before it. That level of rigor matters enormously in a field that has been embarrassed before by premature announcements. Distant galaxy candidates are initially identified through a much cruder method, essentially estimating distance based on how a galaxy's color appears across different imaging filters, a technique that can produce false positives when dust, or an unusual mix of elements, tricks the instrument into reading a nearer object as far more distant than it actually is. That's precisely why the confirmation of MOMZ-14 took real time and real scientific caution. The team first identified it as a promising candidate by combing through existing Webb imagery, then dedicated a follow-up observation in April 2025 specifically to capture its full spectrum. And only then, after the data had been thoroughly analyzed and independently checked, did they feel confident enough to submit their findings for peer review. That process, from candidate to confirmed record holder, took the better part of a year, which tells you something important about how seriously the scientific community treats a claim this significant. Nobody wants to be the team that announced a groundbreaking discovery, only to have it quietly retracted months later once someone found an error in the spectrum. This era of cosmic history that MOMZ-14 comes from even has its own name among astronomers. The Rayonization era, a period beginning roughly a few 100 million years after the Big Bang, when the very first stars and galaxies began flooding the universe with enough ultraviolet radiation to strip electrons from the neutral hydrogen gas that filled all of space up to that point. Before Rayonization, the universe existed in what's often called the cosmic dark ages, a stretch of hundreds of millions of years with no visible starlight at all, just a vast, cooling fog of neutral hydrogen slowly clumping together under gravity. MOMZ-14 formed right at the tail end of that transition, one of the very first true places to punch through the darkness and start shining. In a sense, we're not just looking at a distant galaxy. We're looking at one of the first candles ever lit in a universe that had, up until that point, been sitting in near total darkness since its own birth. To understand just how remarkable this discovery is, it helps to look at exactly how the record has fallen again and again in an almost dizzying sequence over the past decade. Back in 2016, using the Hubble Space Telescope, astronomers confirmed a galaxy called GN-Z11 as the most distant known object in the universe, sitting at a redshift of roughly 10.96, corresponding to a period around 400 million years after the Big Bang. For years, GN-Z11 held that title, a genuine marvel of observational astronomy, achieved with a telescope that was never even designed to see that far back in time. Then Webb came online in 2022, and the record didn't just get broken, it got broken repeatedly, almost casually, as though the telescope was systematically working its way toward something. JADA's GS-Z14 and 0 took the crown next, confirmed at a redshift of 1432, corresponding to less than 300 million years after the Big Bang. And then, barely more than a year later, MOMZ-14 edged past it, at a redshift of 1444, currently the reigning record holder for the most distant confirmed place in the observable universe. Notice the pattern in how quickly these records are falling. That pattern is not an accident, and it's not going to stop. NASA itself, in announcing the MOMZ-14 discovery, stated plainly that it fully expects this achievement to be surpassed in the not-too-distant future as observations continue to improve. This isn't a case of scientists being modest. It's a case of scientists being honest about the trajectory of their own field. And the timeline for that next leap forward is not vague or distant. NASA's Nancy Grace Roman Space Telescope, an instrument purpose-built to survey enormous swaths of the sky far faster than Webb's narrow deep-focus imaging allows, launched in 2026, where Webb excels at staring intensely at tiny patches of sky to find the faintest, most distant objects hiding within them. Roman is designed to scan huge regions of space quickly, systematically hunting for exactly the kind of rare, extreme, record-breaking galaxies that Webb has to search for almost by accident. Naidu himself acknowledged this directly, saying that to figure out what's actually happening in the early universe, astronomers need more detailed observations from Webb and more galaxies from Roman to see where the common features actually are. In his words, it's an incredibly exciting time, with Webb revealing the early universe like never before and showing us just how much there still is left to discover. So if MOMZ-14 is likely to lose its title soon, why does any of this matter? Why should you care about a temporary record holder in a race that's only going to keep resetting itself? Because the point was never really about the number. 33.8 billion light years, redshift 1444, 280 million years after the Big Bang, these are just coordinates. What actually matters is what keeps happening every single time astronomers push a little further back. Every record-breaking galaxy, from GN-Z11 to JDES-GS, Zsharp-13-0 to MOMZ-14, keeps arriving brighter, denser, and more chemically developed than theoretical models say it has any right to be. This isn't one lucky anomaly, it's a consistent trend, repeating itself at every single new distance milestone, and it's forcing a genuine reckoning inside cosmology about how quickly the universe actually learned to build galaxies in the aftermath of its own birth. There's also a deeper, almost philosophically dizzying layer to all of this, one that goes beyond even the most distant confirmed galaxy. MOMZ-14 is the most distant known place, the farthest specific location we've actually identified and measured. But it is not the edge of what we can theoretically observe. That boundary, called the edge of the observable universe, sits even farther out, at roughly 46.5 billion light-years in every direction, marking the absolute limit of how far light has had time to travel to reach us since the beginning of the universe. Beyond that boundary lies the cosmic microwave background, the faint, ancient afterglow of the Big Bang itself, radiation that has been traveling toward us since the universe was only about 380,000 years old, long before any star, galaxy, or structured place had ever formed. That afterglow isn't a place in the way MOMZ-14 is a place. There's no galaxy hiding in it, no specific location with coordinates and a name. It's the boundary itself, the wall at the edge of what light has had time to show us. Everything we will ever discover, every future record-breaking galaxy, every distant place still waiting to be found, exists somewhere in the vast space between MOMZ-14 and that ancient wall of light. Think about what that actually means. There is a real physical gap of hundreds of millions of years sitting right now in that space between the most distant galaxy we've confirmed and the absolute edge of what we can ever hope to see, filled with galaxies, structures, and places that formed even earlier that we simply haven't found yet, because no telescope has managed to catch their light and confirm their distance. Some of them are almost certainly out there, hiding in patches of sky nobody has pointed a sufficiently powerful instrument toward yet. Webb is still operating, likely for another 15 to 20 years based on how efficiently it used its fuel during launch. Roman is now scanning the sky specifically built for this kind of hunt. And somewhere in that overlap of two of humanity's most powerful observational tools, working in tandem, there's an extremely good chance that the record set by MOMZ-14 gets broken again, possibly within the next few years, possibly by a margin large enough to reopen the entire conversation about how early, how fast, and how strangely the first true places in our universe actually came into being. For now, though, the title belongs to MOMZ-14, a galaxy, real and specific, sitting at a genuine location in space, 33.8 billion light-years from where you are reading this. A place that existed just 280 million years after everything began, glowing brighter than it should, built faster than the models allow, and quietly forcing some of the most respected astronomers on the planet to admit that the story of the universe's earliest days is nowhere near finished being written. Somewhere out there, past that light, past that record, past the edge of what we've confirmed so far, there's almost certainly something even older, even farther, even stranger, patiently waiting for the next telescope, the next survey, the next moment when its ancient light finally finishes its impossibly long journey and lands, at last, on an instrument built specifically to notice it.